for Prof to join us. He's here. Welcome.
Hello.
You're early. Well done.
If I join early, it's problem. If I join late, it's problem.
I wonder if we have new people. Do I need to introduce you?
No, you
Do we
don't. We
have new
don't.
people?
I don't think we do.
Okay. All right. Well, we'll take your word. So thank you everyone for joining us. If you've joined us before, then you would know the rules. If it is your first time joining us, we will have a Q&A session at the end of the presentation, but you're welcome to post your questions in case you don't want to forget them throughout the session, but we will only read them and answer them at the end of the presentation. We will also issue certificates. Today is day 1, tomorrow day 2, so you have to attend both sessions, and then you will receive your certificate next week sometime. We will send out an attendance register at the end of the presentation. So once Prof is done, we will share an attendance register. It is a link. You need to complete it. Please provide your name. Well, make sure that it's spelled correctly, even your email address. Please make sure there are no typos so you can receive your certificate next week. Yes, we are going to have you will have access to the recordings. Actually, we're streaming live, so you will be able to access the recording on our YouTube page, LinkedIn, even Facebook, but most people usually access it on YouTube. So we will share the links during the session. So thank you so much. Do enjoy the session. Prof, you can take
All
over.
right, sure. Thank you. All right, let me share my screen. Can you please enable sharing? Okay, I think I can share now. Let me know when you can see my slides.
Yes, we can see them.
All right, good. All right, welcome everybody. So today's session will be a condensed version of the workshop we had at Harvard a few days ago. So we had a 2-day workshop that was all day long on each of those 2 days. So we're going to try to compress that into 2 hours for today and tomorrow. So what we did on day 1 of the workshop we'll present today, and what we did on day 2 we'll present tomorrow. So today we're just going to focus on the principles of study design and then try to operationalize those with an actual example. So today will be about data collection, study design, and all of this good stuff. And tomorrow will be about the analysis and the writing and interpretation. All right, let's get started. So any observation or any phenomenon we observe in the universe can be explained by one of 3 phenomena. It could be the truth, it could be chance, or it could be bias. And that is why we sometimes say that epidemiology is the science of truth, chance, or bias. So everything you see, you might be saying, oh, that man, that millionaire guy, did he get wealthy through legitimate means? You could say, well, it's the truth. Yeah, I think he's truly a millionaire through hard work. Or it could be chance. Oh, he just got lucky and he won the lottery, right? Or it could be bias. Maybe he gamed the system. See, so everything we see in the world, whether it's research or non-research, can be explained by one of these 3 factors. The same applies to research. Any finding we see can be attributed to either truth, chance, or bias. Obviously, our goal as researchers is to get to the truth, but that means that we have to find a way of dealing with chance and with bias. And that's the whole point of research. How do we isolate the truth from chance and from bias? So what does research mean? Well, research means to research. In other words, to search over and over. So the question is, what are we searching for? Well, we're searching for the truth, right? And then why do we have to search for it over and over? Well, it's because the truth doesn't just hang around in space in a clean, tidy fashion. The truth always lies in the gutter. So when you pick the truth from a gutter, it is filled, it is covered in filth, it is covered in chance, it's covered in bias. And we need to clean those things away to reveal the truth independently. So that is why we have to search over and over, because the truth lies in the gutter, right? And that's the whole point of research, to search over and over for the truth and nothing else but the truth. And so research means that we are trying to generate new knowledge through systematic inquiry to identify the truth. Now, there are two types of truths. There's the whole truth, which is the one in green on the left-hand side, and then there is the whole truth. Well, put it might sound like whole. So the whole truth with the one in red means it has holes in it. Now, why does it have holes? Well, it has holes because we have not cleaned the truth from chance and from bias, right? Remember, the truth lies in the gutter. When we pick the truth from the gutter, we have to clean, away chance, clean away bias to make sure it's the whole truth, the green truth. When we fail to do that properly, we end up with a truth with holes, and that's not good. We want to make sure that our truth is the whole truth and nothing else but the truth. But that's the whole point of research, right? To search over and over to make sure that we've cleaned this truth over and over until it's clean and it's free of bias and free of chance. Now, if we say that research is the pursuit of truth, the question is, what is truth? Well, there are two types of truths. There's truth in the study and then truth in the real world. You can think of this, let's think about an analogy. Imagine you fall in love and you're like, oh, this person is my, what are some of the cheesy expressions they use now? It's my, well, this person, I love this person dearly. I can't come up with any cheesy expression now. And so you love each other, you've agreed that you want to marry each other, right? So there is internally between the two of you, there is harmony and truth, and you love each other dearly. That is what internal validity means. It means internally everything is fine, right? The relationship between the exposure and the outcome is very legitimate, and it's true. There is freedom from bias and freedom from chance, right? So you don't have confounders, whether it's you don't have bias, whether it's confounding bias or measurement bias or selection bias. When that happens, we say that, wow, the relationship between this exposure and outcome is so beautiful. It's internally valid, right? But then think of external validity as now, okay, well, these people that have agreed to marry each other, they now go to their extended family. Now, in some societies, you need the buy-in of the external family for your marriage to be legitimate, right? So if the extended family says no, well, things start getting complicated, and that's what you have here. So here you have these two people who love each other, but the extended family says no, we don't like this person. This person comes from a sketchy family, or whatever this narrative is. Now you have a problem because there's internal validity, but there's no external validity. So external validity is the extent to which the extended family accepts the study, the extent to which the findings from your study can be generalized to the external universe, right? The external population, the broader population of interest. So you can see how you can have internal validity, but no external validity. However, obviously, for you to go to the extended family, you must have had internal validity first. So internal validity is a prerequisite for evaluating external validity. If you don't even like each other, then why are you going to the extended family? That makes no sense, right? So those are the two truths we talk about all the time: truth in the study and truth in the real world. Now, if we step back from theory a little bit, our job then is, when we're conducting studies, to make sure that we can control for all of these issues, right? How do we control for bias? How do we control for chance? If we're to control for bias, that means that first and foremost, we must have captured the variables we need. How do you control for something that you don't have in hand. So that means that when we're designing our questionnaires, we must collect the variables we want to control for. We must design our studies in a way that ensures there's freedom from selection bias. And that's what we're going to be doing today to see how all of these things play. And then for external validity, for that to hold, it means that when we drew our sample, we must have drawn it in a way that is random, because randomness is the mathematical basis for external validity. So that means that if we use non-random sampling techniques like convenience sample or volunteer samples or purposive samples, it means that our study may not be readily generalizable to the broader universe, right? So understanding these things is very important because it directly informs our design, whether it's the kinds of variables we include or the kinds of sampling techniques that we use in our study. In general, we want to avoid medicine after death. So it's not that you do the study first and then you say, geez, I wonder about external validity, right? That's not very healthy. Let's worry about those things at the design stage before we get down to the analysis. So that's the reason why we're going through these things. All right, let's move on. So this is also why we do certain things like regression, right? Remember, we always come back to this, that research is the science of truth, chance, and bias. We want to identify truth and exclude the role of chance and exclude the role of bias, right? Let's always remember that. If that's the only thing we learn from today, that's great. That means we've learned something. This also explains why we use things like regression. You've heard of a story of the blindfolded men who were asked to describe the part of the elephants that they were in contact with. One says a rope, one says a wall, and so on and so forth. Question then arises, who is wrong and who is right? Well, they are all right. I mean, the guy who said it's a fan, well, it feels like a fan. I mean, that's what he had contact with. The guy who says, oh, it's a spear. Of course, it looks like a spear. And so he's not wrong. But they're also all wrong because obviously it's not a spear, it's not a fan, it's not a rope, right? The problem with them is that they are too close to the animal, they're too close to the elephant. So for you to see the whole picture, again, remember the whole truth, for you to see the whole truth, in this case, you have to step backwards, right? And that's what we call regression. Regression means to step backwards. I'm sure you may have asked your niece or your cousin, are you regressing or what? I mean, maybe they come back with very bad grades. And maybe last year they had A's and now they're having B's and next year they're having C's. Of course, you're going to ask them, are you regressing? Are you going backwards? So regression means to go backwards. And why are we going backwards? Well, we're going backwards because we want to see the whole big picture, right? We want to see the whole truth, not just some part of a truth, right? So the point of this lecture is just to make sure that we can connect the big picture items together so that those things don't sound like isolated narratives, but we can piece together the big picture of why we do research and why we do certain things and why we have to do some things a particular way. It's to make sure that as we pursue the truth, what we get is the whole truth. I mean, the whole one, not the one with holes. The one with holes has bias and has chance there. And also, I'm sure you've heard of the expression that, oh, one cannot see the forest for the trees. Well, if you're standing too close to the tree, all you're going to see is the tree. You're going to see, oh, this tree is like brownish and has some greenish hues on it. You can only see the tree because you are too close to the tree. If you want to see the forest, you have to step back from the tree. You have to go back, maybe in an airplane, all the way back. And then in that vantage point, you can look down and say, oh, wow, now I can see the whole forest. I can see that, oh, some parts of the foliage, some parts of the forest have, green leaves and some have orange hues and so on and so forth. The only reason you could do that is because you have stepped back, you have regressed. That's the exact same thing we do in analysis. We regress so that we can see the whole big picture. And that's why we do things like regression analysis, so that we can see the big picture patterns in overall data, not just individual data points like this tree. That's also why, all of us, we've never seen, unless you've gone into space, you have never seen a picture of the Earth like this, which is quite an interesting idea when you realize that we are all standing on the Earth right now. All of us have our feet on the Earth now, but none of us can see the Earth in this form. Why? Because we are too close to it, right? For you to see this picture, you have to go into space. And again, you have to regress. Now, we also have to understand the idea of models, right? We talk a lot about regression and models. The idea of this brief lecture is to connect those dots together for us so that we see the big picture of why we do certain things in our quest to research. Again, remember, research means to search over and over for the truth. Now, here is a picture. This is the picture of an apple, or a model of an apple. Now, the question you might ask is, why do we need a picture of an apple? If somebody has not seen an apple, obviously it makes sense that we give them a real apple so that they can appreciate the apple. But sometimes we may not have a real apple. You might be in part of the world where apples do not grow at all. You might be in a war-torn area where everything has been destroyed. But children still need to learn A is for apple. Imagine how absurd it would be when you say A is for apple, but there's no picture of an apple, right? So in many, many scenarios, we need an apple, even if we don't have an apple. Now, of course, we acknowledge that the picture of an apple is not the same as an apple. You can't eat this apple, you can't smell it. But even with those limitations, it still has advantages. It still allows somebody who has never seen an apple before to appreciate what it looks like, right? And that's what models do. This is a model of an apple. The same thing when we generate models, mathematical models, what we are doing is we are saying, oh, well, I don't have the apple, which is I don't have the data, but let me show you a picture. Let me show you a model. Let me show you an illustration of what it looks like. Of course, you should bear in mind that this is a simplification. This is not a real thing, but it's what it kind of looks like. That's what models are, right? Models allow us to simplify reality in a way that we can explain how the world works to somebody who doesn't understand the big picture. And that's why we do modeling. Again, why do we do that? Because we're searching for the truth. So notice that now we have shifted our focus from search for the absolute truth to the search for the best available version of the truth. So the moral of the story is that sometimes we just have to settle with what we can get, not what is ideal. What is ideal in this case is to give the person an actual apple and say, this is the truth of what an apple looks like. That would be ideal. That would be great, right? But in many instances, we can't do that because we don't have the data. So the pursuit of truth in that case then means what is the best available version of the truth? Then we have to provide a simplification, a picture, or a model. A model is a picture, right? And say, well, this is a picture of what an apple looks like. But even in doing so, we must make sure that there is no chance. We try to eliminate the role of chance, even in that simplification. And we try to eliminate bias as much as we can so that what we're presenting is the truth and the whole truth, right? So that's why we do research. And so in our from the very beginning, where we're trying to conceptualize our research, where we're trying to ideate the process, all the way through the analysis, we have to constantly think of bias and chance and truth. From our questionnaire design, we have to think of, geez, are we measuring the truth? What are some of the biases that we need to account for? Every single stage, you have to worry about truth, chance, and bias, right? And your job is to isolate the truth. Remember, the truth lies in the gutter. Your job is to make sure that as you extract the truth, you clean it very well so that it's the whole truth and nothing but the truth. And that you collect the right variables, right? Every researcher needs to be aware of these key variables in research. And the reason why you need to be aware of them is not for some sophisticated reason. It's just because you need to collect those variables. You need to know what variables to include and what variables not to include. When you collect data and let's say you're fitting a regression model, you're trying to do some analysis, and you add things that you should not add, that's a problem, right? It's a big problem for us. So that's why these big variables are important, so that when we are designing our study, whether it's data collection or whether it's analysis, we know we don't do too much. That's the whole point. That's what we're trying to say. Don't do too much. Collect the things that are needed and account for the things that are needed. But don't be adding unnecessary stuff that is not needed because you're doing way too much, right? Don't do way too much. So exposure is what we're interested. Okay, let's go to a simplified version of this. This exact same slide is what I have presented here in a simplified version, right? This is your exposure. This is a tank. And here, this is your outcome, the basin here. Our research question here is simple. How long does it take for water in the tank to empty into the basin? That is the research question. And this is the pipe we're interested in, which is what we call the causal pathway, right? So the research question is simple. We have water here. I want all the water here to drain into this particular basin. And we're interested in how long does it take? Now, if there were no other pipes, that is a very simple question. We'll just sit down and time the entire thing. But here we have many, many other pipes that create problems for us. And that is the whole point of research, that sometimes the research question we're asking is not just that simple. There are other things, there are other pipes in the background that we need to take care of. Imagine this pipe now. There's another pipe here that is also taking water from the exposure and all the way to the outcome basin, right? So if this was the only pipe, maybe it would take it 1 hour for all the water in the exposure to drain into the outcome. But now we have this pipe here that is also transporting water. So you might end up with an answer of 15 minutes. It takes 15 minutes for all of the water in the exposure to drain into the basin. But that is not the real answer, is it? Because that you are now counting the effect of the confounder. So confounder variable is a variable that is associated with the exposure and with the outcome, but it's not on the causal pathway. See, it's a different pipe of its own. So when we're collecting data, we need to think about confounders. What other pipes could be transporting water from the exposure to the outcome that are not on the causal pathway we're interested in, right? You have to control. So if there's a confounder, your job is to collect information on that confounder. We don't want a scenario where you design a questionnaire and you now say, oops, we don't want to hear any oops from you, right? So we hear oops when you now collect data and you say, oops, I forgot to collect information on that confounder. No, that's a capital sin, right? We can't allow that to happen. So that's why we're having this lecture now. As you design your questionnaires, think through all your research question, your exposure, your outcome, and think of what confounders are there that I need to collect information for. Obviously, if you cannot collect information for it, you cannot control for it. So this is the first problem we have, the confounders. Let me minimize this. Okay. So the confounder is the first problem we have. So we have to control for it. But for you to control for it, you must collect information for it. And that means, in simple language, you must include that variable in your questionnaire. So now we have our exposure, which must be in our questionnaire, obviously. We have our outcome, which must be in our questionnaire, obviously. Now we have our confounder, which we also must collect information for. You may have multiple confounders, so you have to collect information for all of them. Now, we have another variable here called the mediator, right? As you can see here, this mediator just connects to the main pipe and drains water from there. Now, what could that happen? What could that result to? Well, it could cause many things, right? One, the time, it's stealing the thunder from the main pipe. If we're interested in not just the time, but also the total volume of water that came out from this pink pipe, we might come up with an answer that might not reflect reality, right? Obviously, it's very clear that because this pipe takes its life from this pipe, it reduces the amount of water that comes out totally from this pink pipe. So if we were supposed to have 100 liters come out from the pink pipe, you might end up with just maybe 50 liters because some of that water that was supposed to come out here has been diverted to this pipe. So this happens when we have an exposure and an outcome, and you are controlling for a variable that is on a causal pathway. For example, let's say our research is the association between exercise or physical activity and, let's say, heart disease. But you know very well that if you are not physically active, you might have high levels of, let's say, cholesterol, and then that would end up with you having heart disease, all right? Now, imagine that you are fully aware of this pathway. Low levels of physical activity results in high levels of cholesterol, which results in bad cholesterol, which results in heart disease. But in your analysis, in all your wisdom, you chose to adjust for cholesterol levels. Well, that's really bad now, right? Because it's like you've inserted a pipe, this purple pipe, that is now stealing water from the main causal pathway. So you end up with less water here, which means that in your study, you end up with a smaller odds ratio or a smaller effect size because you have adjusted out the relationship. So this means that you do not want to include this in your model, right? Because it's going to distort the story. It is no longer the whole truth, the one with green. It's now truth with holes, which is not a good thing at all, right? And that's why we need to know these things and to account for them or not account for them. Some of them are things we'll just leave for now because they're not directly linked with our session today. Some of them are tomorrow, so we're going to tie them to tomorrow. But the big picture and the big moral of the story is that when you want to do a study and want to collect data, your first job is just to sit down and think. You don't need any tools. You don't need any fancy software. You need your brain and a piece of paper, and you need to think about the study. And you cannot outsource this job to anybody else. You can't say, hey, what variables do you think I should include in my analysis, or in my questionnaire? It's like, it's your study. You should be the one telling us. So think carefully about the causal pathway, right? And think of all the variables that could be confounders and, the exposure and how to measure it and the outcome. The covariates are also important. Covariates are variables that are associated with the outcome, but not directly with the exposure. In this case, water from the cloud is pouring directly into the basin. But that's not the research question, remember? The research question is how long it takes for water from the tank to empty into the basin. But now we have some extra water that is not coming from the basin that we have to adjust for, right? That's why we sometimes include covariates in our models because they explain some of the variation in the outcome that is not attributable to the exposure. But that's not the question. The question is exposure and outcome, right? So when you hear of covariates, it shouldn't be just be, oh, we're doing these things because this is how people always do them. You need to have a solid understanding of why things are being done a particular way or not done a particular way, and why we may need to adjust for a particular variable, in this case, the covariates. And then sometimes doing too much results in problems. When you're selecting variables, for example, that will be part of your inclusion criteria, you want to avoid serious mistakes that could inject bias into your study. For example, when you include variables like colliders, right? You can see here that this is our confounding pipe, and this is our exposure. Now, a collider is a variable that is associated with the exposure and with the confounder. So you see this pipe connects the exposure and the confounder. Now, when all is well, if this pipe doesn't have a hole, there's no problem. It's not causing anything. When it has a hole, you can see that the water is diverting from the tank into somewhere else. That's not good. That completely distorts our research question. The research question was, how long does it take for all the water in the tank to end up in the basin? Well, when we have a collider, we condition on the collider. Condition means that we include that as a condition for our study. Then that creates problems, right? A very good example is, imagine your study is about the relationship between physical activity, or let's say smoking cessation, and weight loss. Are people who quit smoking more likely to lose weight? That's the research question. The confounder here is health consciousness. People who are health conscious are more likely to quit smoking. People who are health conscious are also more likely to be on a keto diet, for example, to lose weight, right? Now, imagine that in your wisdom, you decide to say, well, I'm going to include as a criterion for this study people who are enrolled in a gym. Now, gym membership is a variable that is associated with both your confounder and your exposure. Remember, your exposure is quitting smoking, and your confounder is health consciousness. So people who are in a gym, enrolled in a gym, are more likely to be health conscious. They're also more likely to want to quit. That's like conditioning on a collider. In other words, you have made a collider to be an inclusion criteria for your study. So now your study is made up of only people who are going to the gym and working very hard and losing weight all the time. So remember, your research question was, does quitting smoking make you lose weight? Well, you might come up and say, well, no, it doesn't. In reality, when you quit smoking, you actually gain weight. But you cannot see the weight gain, because these guys are going to the gym all the time and they're losing this weight all the time. And that prevents you from seeing the actual relationship you wanted to explore. So in this case, you need to be aware of those relationships so that in this case, you should not have done it. You are doing way too much. You should not have included that as your inclusion criteria, right? So the bottom line is that we need to be aware of this, not just to sound sophisticated or sound cool, but to know how that influences decisions in our study. For example, decisions as to our inclusion criteria, what to include as the inclusion criteria, decisions as to what variables to collect or not to collect in our questionnaire, and what variables to analyze at the end of the day. And also, we need to know the hierarchy of studies in epidemiology. So I'm sure all of us know this, but the bottom line is that we have descriptive studies and analytical studies. Descriptive is just like, telling a story, describing things. Analytical means comparative. So we need to know that. The bottom line is, how do we classify these things? You start with the question, are groups being compared by exposure status? If it's yes, then the study is analytical. If it's no, it's descriptive. If groups are being compared, then the next question is, who assigned these people into groups? There are one of three entities that can assign people into groups: nature, nurture, or the investigator. Nature is nature, where you were born, things that you had nobody had control over, right? Nurture is your own lifestyle choices or your environment. So if the assignment was done by nature or by nurture, then we say the study is observational. If it was done by the investigator, we say it's an experiment. And if it's an experiment, if it was randomized, we call it a randomized control trial. If it was not randomized, then it's a non-randomized trial. So we need to understand these things. On the last note, one of the major confusion areas usually arises from the distinction between prospective cohort studies, retrospective cohort studies, and case control studies. So let's break it down in a way that is easily understandable. Imagine that you have invited a chef to cook a dish for you, right? So in all instances, the chef has to gather the ingredients and to then cook the meal, right? Every single of the scenarios, the ingredients must come before the dish. Obviously, that should make sense. No dish just comes out from outer space, right? The ingredients always precede the dish. In the same way, the exposure always precedes the outcome in reality, in the real world. Now, the difference between these three studies is what happened and where you were. So in scenario number one, you were with this chef all at the very beginning. You saw the chef put together the ingredients and mix things, and you were taking your notes, and you were there till the meal was cooked. That's what happens in the prospective cohort study. You are there at the very beginning, right? People are, exposed or non-exposed at the very beginning, and you follow them over time. You can see when they develop outcomes. You can see when things happen. You are there, you're observing with your two eyes, right? And taking notes when things happen. So that's why it's called prospective cohort. In the retrospective cohort, the chef came, but you were unfortunately not around. So you had maybe traveled. So, but the good thing is that you had left your recorder on. And so the recorder recorded the chef as they were cooking and mixing things and when they left, right? When you came back, you can now go back and play the recording and observe as though you were there and watch how things were mixed and all of that. So in a retrospective cohort study, we come at the end of a show that will go back in time by reviewing records and putting records back together and say, okay, let's repiece the history together and then observe it as though we were there at the very beginning. That's what happens in the retrospective cohort. So the distinction between the prospective and the retrospective cohort is that here we are there before the dish has been cooked. The dish, has been cooked. And in a retrospective cohort, we come after the dish has been cooked, but we're going back in time to look at the recording and see how we can piece together the story together. Now, in the case control study, we come when the dish has been cooked, and alas, we don't have a recording. So we have to play detective. We now have to, dismantle this dish and break it apart and say, this outcome, I can see something that looks like an onion. So maybe this guy used an onion in this dish, or this smells like garlic. I'm sure he used garlic, right? That's what you're doing here. So with the case control study, the outcomes have already occurred. And what we are trying to figure out is the exposures that went into it, right? So when we're discussing studies or trying to design studies, we need to know where our study falls among these analytical studies. And then PICO or PICO or PICOT, you can call it however you want. When we're designing our study, it's very helpful for us to conceptualize our study based on this framework. We have to say, what is my population? And what is my intervention? What's the comparison group? What is my outcome? What time periods will this cover? And what is the study design? Will it be, cross-sectional? Will it be cohort? If it's a cohort, am I going to use a prospective cohort, a retrospective cohort? Is it going to be a case control study? Or do I want an experiment? Those are the decisions that you have to make. You, as an investigator, this is your job. You have to define all of those things. So always get a good diary, get a good writing pad, and write. So again, I cannot emphasize enough, study design is not about technology or about software or about any fancy stuff. It's about you, your brain, and a piece of paper, and you putting out your thoughts on paper about what the study is going to look like. Because those are decisions that you have to make, right? Now let's finally talk about the inclusion and exclusion criteria. Most times you see people interchange these two things. The way people word it, you think that inclusion criteria and exclusion criteria are opposites of each other. So they might say something like, inclusion criteria for this study was you had to be a male. And then they might say, exclusion criteria is being female. that's not what it means. Think of inclusion criteria like putting your arms around a population and saying everybody within my embrace is part of the study by inclusion criteria. So everybody who falls within your embrace has met the inclusion criteria, and anybody who falls outside of that embrace has not met the inclusion criteria. So everybody in this cycle has met the inclusion criteria, and all the red guys have not met the inclusion criteria. They have been screened out by the inclusion criteria. Now, for the exclusion criteria, I can now look inwards among the guys in my embrace and say, well, you, and you meet the inclusion criteria, but for some reason, I have to remove you out of the study because you do not meet my, you're ineligible by means of the exclusion criteria. So exclusion criteria applies to individuals who have already met the inclusion criteria, but for some reasons are not eligible, for whatever reasons you define. All right, so today, what we're going to do next, we're going to now leave the theory now and go into hands-on and say, okay, how does these things work in practice? How do we take a research question come up with a very thorough conceptualization of what we need for the variables that are going to be captured in terms of the outcomes, exposures, confounders. How do we calculate the sample size for this study? How do we create the questionnaire and add intelligence to the questionnaire in terms of inclusion criteria, exclusion criteria, like all the stuff we've talked about? How do we operationalize them? How do we pay attention to issues of bias? Remember, I talked about confounding bias, measurement bias, and selection bias. So for measurement bias, how do we make sure that the information we're collecting is accurate, that people are not giving us data that is dirty and we have to clean later? How do we make sure that at the very beginning that we put in guardrails to optimize the quality of the data we're going to receive? And then finally, how do we then, at the end of the day, make some changes to the data to make sure it's fit for analysis? So that's what we're going to cover in the second part of our class now. Does anyone have a topic that they want to volunteer for us to use for this exercise? I always prefer using topics for volunteer because then it makes it more relatable. Well, at least to the person who submitted the topic. So if you have a topic that you'd want us to use, you can just drop it in the chat, and I can then use that for our session now.
There's one, but okay, there's one: innovation adoption in mega projects.
Okay. That is not very clear at all. What you have try to make sure that the suggestion you is in plain, simple language. So want something that is more descriptive.
The economics analogy of Mission 300 project.
What does that mean exactly?
Effect of fuel subsidy removal. Oh, okay, now they're coming real quick. Okay.
Okay.
Exploring the practice of dental hygiene among Sangaya students in Kano State, Nigeria.
All right, so look, just give me one that is good, and we can just use it. You're going to choose one for us. So pick one. I want you to pick something that is relatable to most people, that most people can relate to, and then we can then use that as the basis for our their collection. Let me know when you've done that.
Right, I'll choose this nutrition one.
Okay.
Assessing the impact of health education at primary healthcare facilities on community nutrition specific interventions, addressing malnutrition in under 5 children in Ibadan.
Okay. All right. All right. So that's what the Oracle has chosen for us, and that's what we'll do. All right. So let's get over to the Chi-Squares platform and let's see how we can implement all of these things we've mentioned, right? So as usual, we said we want to ideate on the study. Don't just jump into any technology that you want to, okay, I want to do the study, and then, hey, what software should I use? No. Don't talk about software yet. Just talk about the study design first. So let's do that now. Let me pull up let's open a notepad on platform and let's look at the ideation of that. Let me sign in quickly. All right, so let me open a document and let's think about the ideation of the research that we've talked about. Let me just open the documentation page. So let's talk about research ideation. All right, so now this is the topic. Let's put the topic here so that we can start. Lumina, please confirm you can see my screen clearly.
We can. Okay. Yes, we can.
Okay. So I'm going to go into dark mode. So it's easier on my eyes that way. All right. So that's the research question that was recommended. So let's start with the PICO, right? Remember we said we'll start with PICO, population intervention, control, outcome, time, and study design. of course, in descriptive studies, you don't have intervention or control. So those, not all elements of the PICO framework might apply in your context. So, so here, the population here is on the 5 children aged, so let's just put population equals children aged 5 years or younger. Try to avoid the word "and" when you're using this kind of descriptives. You can't be 5 years and younger than 5 years at the same time. So it's always or. But the design of a study or the nature of a study population means that we will obviously have proxy respondents, right? The children who are age 5 years or younger cannot talk for themselves. So that means that in defining the population, we also have to define who is the respondent, right? Who is the respondent? Who is the proxy respondent? Respondents can be either self, which is I am responding for myself, or it could be proxy, which is the parent. So this could be parent or guardians, right? So that means that we have to start thinking, okay, in this case, I have to collect data on this child. I want to make sure that the parent, that this is actually the parent or the guardian, right? So now we're already thinking of how this affects the kinds of questions that we need to collect in our questionnaire. All right, so that's that for the PICO. This is a descriptive study. So instead of PICO, we can change this to PECOTS. So in other words, we are switching out I for intervention with E for exposure, right? Remember that every intervention is an exposure, but not every exposure is an intervention. And so here we're looking at the impact of health education. So that happens to be our exposure of interest. It's not an intervention because the investigator is not the one assigning people to be educated or not educated, unless we are doing an experiment where we assign some facilities to some kind of health education and others to the standard of care, right? But for here, we'll just take this at face value and say that the exposure is simply whether or not they've received or the dose of health education they've received in the facility at some point in the past 12 months. So health education, right? Now, this is not very well defined. This is what does health education mean, right? You want to narrow down to to something that makes sense, something that can be easily measurable. So we'll have to then, as part of our job, is to say, what does health education mean? Is this health education regarding let's say formula or breastfeeding or nutritional supplements? What kind of health education are we referring to? As the investigator, these are some things that you need to clarify very, very well. For the sake of this demo, we're just going to talk about, from a very broad angle, but we're just emphasizing that these are some things that you want to pay attention to. You also want to make sure you clearly define the time period that you are referring to. Is it health education received at any point in their life? Is it health education they received in the past 6 months, in the past 12 months? Take note that in survey design, we avoid things like, we won't say health education in the past year. We rather use things like past 12 months. When you say past year, different people interpret that in different ways. For some people, they may think that past year means 2024. Other people may think that past year means, from this month backwards 12 months, in the past, right? So you want to create questions in a way that everybody interprets them in the same way. Now, that's our exposure. But again, the investigator was very particular about the residents being in this place, right? So we might want to also make sure that we clarify that the study population must include individuals who are living in that state, right? So we might want to generalize from just Ibadan to say, let's say, the whole of Oyo State, and say you must be 5 years or younger, your parents or guardians must be residing in that state, right? Because it's possible that you might have people who are visiting but don't live in that state. And so they're not part of your eligible population. That matters because when you're setting up your survey, you have to make sure that it captures only people who are eligible are allowed to come into the survey. So let's say as part of our population, we're defining that as parents or guardians who live in the state of Oyo State, the state of Oyo, who live. Okay, so that's part of our population as defined by the original question. So the exposure here is, health education received in the past 12 months. In the control group is implied as individuals who have not received that education. So when we are designing our questionnaire, we want to pay attention to elements of dose, right? We want to capture the dose of health education in terms of the frequency, right? Like how frequently. So if you receive education, for example, every week you attend, or every time you attend the healthcare facility, that is quite different than if you just were exposed to it only once, right? So for things like this, the dosage matters. So we have to collect information on frequency and the amount, so like how much time was spent discussing with them. Again, those are some of the details that the investigator will want to account for as a designer questionnaire. Now, the outcome is, so the assessing the impact of health education at primary health facilities on community nutrition-specific interventions, addressing malnutrition. So let's say the outcome is some indicators of malnutrition. So this question needs to be also refined a little bit to make it much more specific and straight to the point. There are lots of moving parts there that would benefit from being much more streamlined. So let's say here, however, that our outcome is malnutrition, right? And we have to define it properly. If you're in that field, you need to know how it's defined. Sometimes we will have what we want to capture, but then there may also be some operational definitions that we may use in our survey to get at what we want, right? So malnutrition, that's a very big word. So how can we break down that big word in a way that little people can understand, right? It's all about making sure your survey is simple and understandable. So how do we measure malnutrition? We can't just ask people, are you experiencing malnutrition? First of all, that's a big word. And then, they may not understand it. So we may have to come up with alternative measures that allow us to get at that same topic. We might consider, for example, concepts of, for example, food insecurity, right? Like, are they experiencing food insecurity? Now, that is a more concrete thing to measure. So, it could be, for example, in the past 7 days, on how many days did you not have food to eat, or measures of that nature. So there's the one thing we want to measure, and then on the other hand, like, how do we measure it in a way that makes sense to people, right? Again, as an investigator, your job is to break down those big concepts into smaller concepts in a way that if you ask people, they can understand. Because remember, when you design your questionnaire, don't just design a questionnaire and boom, you launch it. You have to make sure that you test the instrument. Cognitive testing means that we are making sure that when we ask people a question, what they are answering is actually what we are asking. That we mean ABC and they don't understand it as XYZ, right? If we are asking the question XYZ, everybody must understand it as XYZ. If some people understand as ABC and others understand as XYZ, then we have trouble on our hands. People don't understand the question. It's not a good question. So part of cognitive testing is that when we come up with our questionnaire, we now have to ask these people, okay, when I say XYZ, what comes to your mind? What do you understand by that, right? And then you hear the responses. And then it's like, oh, okay, what you answered is not entirely what I had in mind. What I meant was this. And that's feedback that you don't take, and then you address in your questionnaire to make it more clear. That's what we call cognitive testing, that exercise of making sure that what you are asking is what you are getting. If I'm asking for A and I'm getting B, oh, obviously that doesn't make sense. And so part of cognitive testing is also making sure that our instrument is non-leading, right? We're asking leading questions. Leading questions will be questions like, how harmful do you think smoking is? It's like, well, I don't think smoking is harmful. So why are you asking me about how harmful it is? A more balanced question will say, how harmful or not do you think smoking is, right? So that way, I'm not implying that it's harmful or not harmful. I'm just trying to get what is in your mind. So we'll come to this. Then so food insecurity, we can define it however we want in a way that makes sense. And then the other elements of PICO will be the time. So in other words, are we trying to make this a cross-sectional study or is it longitudinal? A cross-sectional study means that we collect data at one point in time, right? A longitudinal study has follow-ups where we follow up people over time to make sure that, we follow them up. And so we get information from wave 1 and then wave 2. So we have to decide, and that's, as the investigator, that's your job to decide what kind of design do you want. And so for the sake of this stuff, we're just going to assume that it's just going to be a cross-sectional study. So that means one single point in time. And we'll set it up accordingly. And then lastly, the study design, okay, the time and then study design. So here we are going to launch it, between so and so months. The survey will be open for, let's say, 3 months, 4 months. You want to open your survey for as long as it takes for you to get a sufficient number of responses. And then, of course, in alignment with the study design as well. So we will take these few elements here and we will then design our study. But while we are doing these things, there are some things we need to pay attention to ensure that the quality of our data is high, right? One, we need to make sure that we collect consent from the parents, right? Parental consent, that's important. So these are some extra things we will need to include in our instrument to make sure that it is fit for use. So parental consent, that needs to be there. Number 2, we need to implement logic, inclusion criteria. So that means that people who are not eligible for the survey should not participate. For example, we may have to ask questions about their country, the states they are living in, since that's the question that's the angle from which the investigator wanted to ask the survey. The states, we might want to ask questions about whether they have a child, that is aged 5 years or younger in the household. And part of our inclusion criteria will be maybe parents or guardians who are age 18 years or older, right? Because just for logistical reasons, we might want to make sure that the people, because you have underage, you have teenage pregnancies and teenage parents who are themselves also teenagers. So we might want to make sure that we are just limiting our study to people who are actually age 18 years or older. So we might ask a question about, for example, their own age. And so those are at minimum things that we want to include in our inclusion criteria. So that means that for you to be part of the survey, you have to be in this country, or if the survey is really only going to be among people in Nigeria, for example, then we don't need to ask country. That's an overkill. So we can ask for state. So for you to be eligible, you must be from your state. You must have a child who is 5 years or younger in your household, and you, the parent, must be age 18 years or older, right? Or older. Then you can be allowed to proceed in the survey. So we're going to show how we can set those things up accordingly. You should never give instructions to people like, oh, don't take this survey if you're not eligible. Nobody reads instructions, right? So don't pass instructions when you can automate things as logic in your survey. So those are some minimum things we're going to ask. And then we may also have to add translation of our survey. Translate our survey into multiple languages. You might want to translate it from English language to maybe Yoruba language or other languages in the area so that people can understand your survey. Other considerations might be offline. You might be going to a part of the state that has no internet. So how then do you implement your survey in offline mode? All right, so those are some of the major things that we want to account for in our survey, right? So let's go ahead and let's set up our survey and see how we can implement those things in real practice. So I'm going to come up to the Chisquares platform and set up a new survey. So for those of you who are not familiar with the Chisquares platform, it's a one-stop shop for research, whether you're collecting data, analyzing data, writing manuscripts, and so on and so forth. Our activity today focuses on, data collection. To access the platform, you'd start from, just go to the website, www.chisquares.com. That's from where you can access the platform. If you have an account, you log in. If you don't, you sign up. So that's that for the access. And so once you log in, it brings you to the dashboard, which is this page. So from here, you can then navigate to where you want. Now, let's quickly run through some of the key elements that we need to think of first in terms of sample size calculation. How many people do we need for our study? To do that, we'll go to data collection and we'll come to sample size. For surveys, the reason why we're doing sample size calculation is to make sure that our survey has sufficient precision. Precision simply means how wide or how narrow our confidence intervals are. So we want to make sure that our confidence intervals are not too wide. So for that, we need to calculate the sample size. For analytical studies, the reason why we calculate sample size is different, is to ensure that our study has enough power, right? So please don't use the word power when you're talking about sample size for descriptive studies, right? Power applies for analytical studies where you want to detect differences between groups. For studies, for cross-sectional surveys, we're interested in precision, not necessarily power. All right, so let's see how we can calculate sample size. So for that, you come to data collection, and then you come to sample size. You click on Start New Sample Size, and you select the study design. So here, we're going to select cross-sectional study with percentage as outcome as our study of interest. Now, when you do that, the platform asks you to supply certain parameters for the calculation. The first is the level of confidence. Generally, we use 95% for that. You can click on the informational icon here, and that explains to you what that particular parameter is. So here, the level of confidence is the desired certainty expressed as a percentage that a true parameter falls within the calculated confidence intervals. That's what that means, right? Next, you provide the prevalence of the outcome. If you don't know what the prevalence is, just enter a value of 50. 50 means 50%. And what is special about 50 is that, think of when we say the country, let's say the US is polarized. It means that 50% agree on something and 50% disagree on that same thing. That is when you have maximum polarity, right? Polarity, the English word is the same thing as variance in statistics. So at 50% prevalence, you have maximum variance, right, for a prevalence measure. In other words, what we're saying is that at 50% prevalence, that guarantees that you have maximum sample size calculated. Because remember, the reason why we're calculating sample size is because we don't know what the sample size is, right? If we knew, we wouldn't calculate it. So the question then becomes, if we don't know what it is, should we rather overestimate it or underestimate it? Well, to be conservative, it's better we overestimate it just in case we get it wrong. And that's why we say, if you don't know what the prevalence is, you can use 50%. The next thing is the population size. By default, the platform uses a a default of 1 million. And the population size here is referring to the population of your study. Here, we're not referring to all the parties, all the people who live in Oyo State. No, no, no. That's not your population. Your population, remember, is people who are aged 5 years or younger in that area, right? So don't imagine that because your study is based in Ibadan, that it is referring to the population of Ibadan. No, it is referring to population of your study population. In this case, people who are aged 5 years or younger. So you put that number. It doesn't have to be super accurate. Sample size is agnostic of the population size. So it doesn't matter whether it's 1 billion or 1 million, right? The only time it matters is when the population size is relatively small, right? And the reason for that is because when in sampling theory, we assume that the sample is very small relative to the population. That the sample is this small and the population is very big, right? In other words, the population is infinite compared to the sample. That's the assumption for sampling. However, when the population is no longer infinite, it's rather relatively small compared to the sample, now that assumption is violated, right? And that is the only time where it matters. So that's why you're asked to put the population size. And what the platform does is in the background, it calculates what we call finite population correction factor. In other words, the opposite of infinite is finite. Finite means that your population is not so big as we imagine. It's rather finite, not infinite. So in that case, we have to correct for it. So that's why you are asked to provide a population size. But in general, as if your population size is reasonably large, it doesn't matter whether it's 1 million or 1 billion. The difference doesn't matter. So you can add as many zeros after this. It won't make a difference in the sample size. Next, you have to provide whether or not you are going to perform cluster sampling. Cluster sampling is if we're going to, for example, survey people in clusters. So our survey might be a survey of, let's say, we're using, child daycare centers as clusters. Maybe we go to a daycare center and we say, okay, we're going to survey, the easiest way for us to get under 5 people are to capture daycare centers. And maybe in the whole of Ibadan, you have maybe 100 daycare centers. So you say, okay, I'm going to select 30 of those daycare centers and sample them so that when the parents come to pick their kids, then I administer the survey to them about that kid. So we're using clusters because here in this case, each daycare center is like a cluster that we're using, right? The problem with clusters is that, well, let's start with the benefits of clusters first. The benefit is that, well, it's efficient. Instead of us going around looking for all the 5-year-olds, well, they're all there in one cluster very conveniently. So it makes life easy for us. Well, the negative thing about cluster sampling is that people who are in a cluster tend to look like each other. Maybe people who attend a particular daycare center all they share some characteristics together. So your survey doesn't have that much diversity as you thought because people in a cluster are correlated. We call that intra-cluster correlation. So that you now have to take a larger sample to account for that. So if you say your survey involves cluster sampling, then the parameters, the platform will say, okay, provide the design effects and other things, right? If you're not using cluster sampling, then it's pretty straightforward. All you have to then enter is a margin of error. The margin of error is simply half the width of our confidence interval. It is asking us how wide of a confidence interval are we willing to accept? So if I'm willing to accept a confidence interval that is 10 percentage points wide, that means that the margin of error is 5. So the width of the confidence interval is the upper limit minus the lower limit. So if my confidence interval ranges from 1 to 11, that means 11 minus 1 is 10. So the width is 10 percentage points. And 10 divided by 2 is 5. That is the margin of error. So the margin of error is simply saying, how wide are you willing to have these confidence intervals to range? So you provide and then the response rate is telling you of every 10 people you invite, how many do you think will respond? So here it's saying, okay, 3 out of 10. And that's just to account for how many people you're going to have in your survey. So once you put all of those parameters, you click on get results. And let me make this get bigger. And then the platform tells you in this case that you need 1,281 participants. In this case, we need 1,281 kids aged 5 years or younger, not the parents, the kids, because the kids are our study population. And then here you can look at, click here to get the reference for the sample size formula that was used. All right, now let's go ahead and create our questionnaire and see how that works. So to create our questionnaire, let's come to data collection and then survey design. We'll then start new survey by clicking this button here. This is just simply telling you that the platform allows for both cross-sectional and longitudinal study. Let me take this thing out of the way. How do I get this out of the way? Hold on a minute. Hide floating meeting controls. All right, sorry. Okay, I give up. All right, so this is just telling you that the platform supports both cross-sectional and longitudinal survey. So let's just get started and set up our survey. There are two surveys, the standard survey, which has all the features, and then the quick form. In this case, we want all the features so that we can set up our logic and all of that. So let's use this standard and start survey. We enter the title of our survey here. So let's call this, let me copy this. All right, this is a very lengthy topic. In general, when you're doing your survey, please keep things simple. So in an actual survey, this will be too complicated for use. Try to aim at a 6th grade reading level. Write as though you are writing for a teenager. So in this case, there are a lot of big words in this title. So we will try to make it shorter and much simpler, right? But this is just a demo. So I'm just going to use things, use them as they are, because our goal is not necessarily for precision, but just to demonstrate. So, but in the real world, please don't use big words. There's a reason why we have small words in the dictionary, which is so that we can use them. So, so that's the title. You can provide your location here for your study. So in this case, our study is, Oyo, Nigeria. The aims of your study, you can type your aims yourself, or you can have the AI generate the aims for you. Here, let me just ask the AI to generate some aims for the study. So let me select a few here. So here it says to determine the barriers and facilitators affecting implementation of community nutrition-specific interventions for 5 children. And then the keywords, again, we can type the keywords or we can ask our AI to generate them for us. So let's generate them with AI. So child wellness is a suggested keyword. Then you have nutritional status and early intervention. Okay, that's enough. Let's add those selected keywords to our survey by clicking here. And now let's create our survey. So now our survey has been created. We can now go ahead and create our questions for the survey. There are many ways we can go about doing that. Let's look at the options we have available. Option number 1 is to create our own questions ourselves from scratch. Option 2 is to copy from an existing survey if that exists. We can copy from the survey bank. We can also import from a Word document. If we had a Word document that already had questions, we can just import them directly. We can also build with AI. For here, I'm just going to do a combination of them. We would create some questions from scratch, the questions that have to do with our inclusion criteria. And then we'll just add a few questions just to demonstrate. Again, this is for the demonstration purposes. So let's go ahead to create a question. Our first question is about where they are living. So let's select that. Let's use a drop-down menu question. Drop down. And let's use that question. Okay. So now let's say, in which state or where do you live? Let's just keep it very simple for demonstration purposes. So where do you live currently? Where do you currently live? All right, so that's the quick question we're asking here. When creating questions for survey, each question must have three components. Your question should have a stem, it should have instructions, and it should have responses. So where do you live? That's the stem of a question. But we must also provide instructions. An instruction, for example, could be, please select one option from a list below. Right? So it's the stem, instructions, and then the options. The options, we can create them. So let's create the options here. Now, when you create the question on the Chisquares platform, you have labels. Labels are what will later on become the variable name. So here you have, for example, this. It automatically creates a label for you, but that may not be very clear or very contextual. So you can either delete this and type it yourself, or you can also ask the AI to suggest an option for you. So here it has suggested options like, leave, right? So, or we can just change this to, for example, state, if that's what we are interested in capturing, which it says, in which state do you live? Now, you can type in the options yourself, or you can use the options supplied by the system. Because obviously you don't want to start typing all the states manually, right? So you can use the options available from the platform. So let's use system supplied options, right? And here we have countries of the world. If you select this, that would select all the countries of the world for you to select, like US, Nigeria, and so on. But that's not really what we're interested in this case. We're not interested in the countries of the world. We're interested in the states in a country. So for that, we will come to this option that says first level administrative units. I will select this option and we would apply. And so let me move that here. So now it's saying, okay, select the country for which you want its first administrative units. So in this case, let's select the country Nigeria. So you scroll down to where the country is, or you just type it and search for it. So all the countries of the world are captured here. So here we have Nigeria right here. So we select that option. Now, when you're setting up your questions, you can look at the preview on this side. The preview tells you how the question will look like when you eventually deploy it. So here we have where do you currently live? Please select one option from below. So when we select this option, you see it has populated the first administrative units from that country that we have selected so that we don't have to now manually have to start selecting all of those elements. All right, now let's push that question to our questionnaire and then create the next question so that we can demonstrate how we can then add those other elements that we discussed. All right, next, let's add the question number 2, which is the age of a parent. So we said that you must be from or your state, you must be aged 18 years or older as the parent or guardian. And you must have a child that is 5 years or younger living in your household. So let's add that question that says, do you have a child or 5 years or younger living in your household? So let's use a yes or no question. So the question is, do you have a child under 5 years old, living in your household. As a matter of fact, let's change the question type from a yes or no question to a multiple choice question. When you're designing your questionnaire, you want to make sure that you ask the minimum number of questions possible to get the same information that you need. So instead of asking whether they have a child in the household and then asking another question to ask whether they are the parents or the guardian, we can fold those two questions in one and says, do you have a child under 5 years living in your household? Let me make this a bit bigger so we can see clearly. Living in your household. Right, that's the question. The instruction is please select one option below. Sorry, for whatever reason, my computer is hanging a little bit below. All right, so that's our question. We provide a question, the instruction, and then we can now type our response options. You can change the label to something that's more intuitive or meaningful. So instead of saying, do you have whatever, I can just type child here as the label. Remember, the label is what will later on become the variable name. The response options here could be things like yes, but instead of simply yes or no, it could be yes, and I am the parent / legal guardian. So the whole reason is just to collapse those two questions into one, because we only want to have that question answered, the questionnaire answered by somebody who is a parent or legal guardian. So when we're constructing our logic, we want to exclude individuals who obviously are not. And so, yes, and I'm the parent or legal guardian. The second option could be yes, but I am not the parent. I am not the parent or legal guardian. And then the next option could simply be no. Right. We can also add, I don't know, because the person may just be visiting, But for now, this is just for demonstration purposes. The goal is not to make it by any means perfect. So let's just push that questionnaire and then ask our question on their age. So now let's add a question on age, and then we can now set up our logic. So let's use a drop-down menu question for this too. When you're asking questions that have numerical quantities, you have two options. One, you can ask a drop-down menu question that allows people to select an answer from an existing option, or you can add a question, an open-ended question like this one here, that allows people to enter an open-ended question. So I'm just going to quickly demonstrate both of them. I will ask the same question two different ways so you can see the options available to you. So the drop-down menu question, let's go ahead and so here the question would be, how old were you on your last birthday? Again, ask questions in a way that everybody can interpret it the exact same way. That's what validity means in questionnaire design. If you just say, how old are you? Some people will give you their age, their last birthday. Some people will give you their age, their next birthday, or their current age. So you won't have consistent answers, right? That results in ascertainment bias where people are interpreting it differently. Everybody must interpret the question the exact same way for it to be valid. So that's why we add some phrases in questionnaire design. So how old were you on your last birthday? Please select one option below. So this is where we are now asking them to select from a fixed set of options. So here we can say this label is age. And so instead of user supplied, we can say, let's use a system supplied options. Oops, let's go back. So system supplied options. And here we're selecting lower and upper limits, right? We select lower and upper limits, meaning that we supply a lower limit and an upper limit, and the system will then fill in the rest. Please select one option below. So here, let's make it clear that responses are in years. Don't ever assume, right? Don't assume that people will know that it's years. Otherwise, you end up with people interpreting things differently. So here, we're going to provide the lowest option as 0 and maybe 200 years as a maximum. And so here in the preview, you can see how they will see the question. How old were you on your last birthday? So you can see the system then allows them to, let's push this to questionnaire. So in this case, they can, respond and then select the option that aligns with what they've selected. So here, the system has filled in the values between the minimum and the maximum option so that the user can then select. That's one way to do it. Another way to do it, if wanted, would be to leave it open-ended so that the user can then simply type their option as desired. So let's create as the last question for this exercise, and then let's set our logic and the consent form and all this. So let's say that we wanted to allow them to type in an open-ended option. So here we'll come to open-ended questions. I will select a single value response, meaning that you're supposed to enter a single value. And let's use that. So again, we'll say, same question. We're just showing different ways of setting it up. How old are you on your last birthday? Right. Then instructions follows. Okay. So I'm just going to leave it at that. Now here we're selecting, you have the option to allow text, but what we're interested in is numbers, numerical response. So you select number. So here they're supposed to enter a number, but you can also set guardrails around what will be allowed. For example, it's possible that some people might think that, let's set some guardrails. So first of all, we can, if we wanted to put measurement units, we can say set measurement units like, days or months or years, but that's not reasonable in this case. So we can leave that as it is, because we've already specified in our STEM that the answers are in years. If we want to allow decimals, we can allow decimals by clicking this button so that people can say, 55.5 years. If you want only whole numbers, then we don't have to check this box. We can also check a box to set minimum and maximum allowed values. So in this case, the minimum allowed value could be 0. You can't have negative ages. Maybe at the maximum is 200, right? But maybe we want to say, well, it's possible that somebody could be 200 years old, but it's not very likely. Maybe if somebody enters 200, maybe they actually meant 20 years. So how do we prevent this? Well, we can check this toggle here to say enable confirmation thresholds, right? What that does is that it allows the system to say, while the upper limits are 200 years, the blue limits are the ones where you can enter without a warning from a system. So if you enter a value of age between, let's say, 0 to, let's say, 120 years, right? And you can type the actual exact value here, that the system should not complain. But should you enter a value in this yellow zone, the system should say, well, are you sure? That seems rather extreme, right? So this is what we mean by soft and hard validation. In this case, the limit of 200 is hard validation. That means that anything beyond that, the system will not accept it. Soft validation in this case is the 120, which means that up to that point, the system will accept it. Beyond that point, but less than the 200, it will accept it, but it will throw a warning that, are you sure? That's rather extreme. So that is what we mean by soft validation. So in this case, the participants can enter the value there, and that's another way you can set up your question. All right, now let's quickly add our consent form and our logic, and let's see how that works. So for consent, we can just come in here and click on informed consent. Again, before you end your questionnaire, you want to really pay attention to those earlier variables we talked about for confounding and all of those things. So let's add our consent form here. So we can click on add form. So we can name the title of our form as consent form. We can indicate whether it's for adults or for whether it's consent for adults or an assent form for minors. You can click on generate default for the system to generate default for you to edit. So it says the purpose of this survey is to gain better insights on this topic. The topic follows. And then you can now edit it to your preferences. And once you're done, let's submit the informed consent. So now we've added consent form to our study. Now let's add the logic, which makes sure that only people who are eligible actually participate. So let's go to question routing and let's add inclusion criteria for our study. So no logic set up yet. So let's quickly set up that logic. Let's add the variables that define inclusion in the study. So the variables were, where do you live? Do you have children under 5 years old? And how old were you on your last birthday? Those are the variables we wish to use to define inclusion criteria for our study. So we'll define them. So if value of state is exactly equal to or your state, so you are eligible for inclusion if you live in the state of Oyo, right? Let's select that. So this is the state here of interest. So we can go ahead and select that. And our operator here is and, so they're all ands. So you live in Oyo, and if value of child is exactly equal to, this is the question assessing for whether they are the parent of the child. And then, and the value of age is exactly equal to greater than, you can now select greater than or equal to. So greater or equal to 18. So this is how you set up your logic for your survey. Let's say 18 here. And there's also flexibility for you to delete items that you don't want to include in your logic. Let's say you only were interested in the states and the age, and you have other questions in the survey, and you didn't, for example, did not want to include this particular variable. You don't have to go back. You can easily delete the logic from here, and then you are left with only whatever values you're left with, right? So there's almost flexibility for you to determine your inclusion criteria with. So in this case here, we're left with logic based on your state, for example, and based on your age. So if let's add this, for example, now. So let's proceed. So the setup of logic is fairly easy. The next question is just telling us things that will appear. So here it's saying that this will be displayed to people at the beginning. If you want to include that, you can save. For those who are not eligible, it's telling them that it will tell them you're not eligible to participate. And then for those who are eligible, it will tell them you're eligible, and then they can continue. And then lastly, this is the, for at the end of the survey. And so this is the logic that has been created. So is that simple, setting up the logic on the platform. All right, now, before you launch a survey, you want to really make sure that you test it. You preview it to see how it's going to look like. So here we can just preview our survey to see how that looks like. Okay. Right. While that loads, geez, my system is horribly slow. All right. So first of all, you see this title is too long. Please, again, we need to practice the art of brevity, right? So less is always better than more. So always try to keep things short, simple, sweet, straight to the point. So but again, let's just go over this. So this is the consent form we added. So in this case, individuals must accept the consent before they can proceed with the study. Then these are the screener questions to determine eligibility, which we then go over, and the study will then evaluate the logic. When you're evaluating your logic, you want to make sure that you test the logic both ways, both in terms of, individuals who meet the criteria, as well as individuals who do not meet the criteria as well. You don't want to assume, never assume. All right, so that's how you preview your survey. For sake of time, I won't go through everything, but you preview your survey. You can definitely practice your hand on setting up those questions and previewing everything to see how everything goes, to make sure that that you're collecting makes sense. All right, so I'm going to stop here since we have time. Oh, we're way beyond time, and take questions from folks as they appear. So any questions from the audience, Lungile?
Yes, let me read the first one here. If a student uses this to create a survey for an MBA or PhD thesis, would they be flagged for AI usage?
Well, you can switch off AI if you don't want to use AI, but it's AI usage is not inherently a bad thing. There's nothing wrong with using AI. So flagging AI in of itself doesn't mean the work is inauthentic. I use AI all the time. There's no work I do that I don't use AI. That does not mean that the work is not original. So yeah, so that's the AI is a tool that is meant to assist us. Now, if you don't want to use AI, you can also come to settings, AI controls, and you can switch off all the AI on the platform. You can say, okay, I don't want to use any AI on the platform. It's not an AI platform. The AI is there to help you. But should you want to, you can put off every single AI off the platform, and you will simply not have it used.
Thank you. Are there mechanisms for supporting survey completion by those who have limited literacy or limited digital skills?
Yes, there are. Um, you can um, you can choose to download the paper questionnaires of the survey. So for the survey we've administered, for example, we can come to our survey and download the questionnaires as barcoded questionnaires. The platform allows you to generate that, and then you can offer them on paper. But if somebody cannot read, that means that it cannot read on the screen, nor can they read on paper, right? So in that case, you might consider doing an interviewer-administered survey where someone reads the questions to them and collects their responses. However, if it's a question of reading English, they can read some local language very well, but not English. The platform allows you to translate your survey into other languages. So you have translations, languages and translations there, where you can then, add languages, to your survey. For example, can choose to add, Yoruba, for example, as part of the languages administered. So that when people are taking the survey here, other languages, they can now select the language under which they wish to take the survey. So these are some of the mechanisms you can use to assist individuals who may have difficulty reading a default language in which the survey is set.
Thank you. Is this platform open source, and must the respondents also log in? Oopsie, I lost that question. Log in to fill the questionnaire?
And so what logged in? Sorry, I didn't hear that part clearly.
Is this platform open source, and must the respondents also log in to fill the questionnaire?
So it is not open source. It has a freemium platform. So you can there's a free account for free users. And yes, you have to log in. You have to create an account to be able to use it.
Yeah, but the respondents do not have to log in.
Oh, the
I
respondents.
think
Okay,
that's
okay.
just the
Sorry,
part.
I missed that part. So you setting up a survey needs to create an account, but no, the respondents don't have to log in. They can just take the survey.
Thank you. Thank you, sir. Can you suggest a modified and brief version of the topic used for this example, sir?
Well, I think you're in the best position to, without knowing the intent of the question or what you're trying to explore, it is impossible. We can modify it in a million different ways based on what the intention is. Research starts with what our intent is. So, as much as I don't know what your intent is, it's impossible. So that's an impossible request because I don't know what you're trying to achieve. The reframing will depend on whether the study is observational or whether it's experimental or, so because of those reasons, that is an unanswerable question.
Thank you. Sir, I have a question on the sample size computation. From my end, when doing the proposal development, I've been always using the population, for example, in a province or country. For case of Kenya, now is that correct, assuming I don't know the population of the study?
No, that is incorrect. Yeah. Kenya, the population of Kenya has nothing to do with your study if your study is among dentists in Kenya. So the whole of dentists in Kenya, you may have 2,000 dentists. That is a population. When we talk about population epidemiology, we mean the target population for your study. We don't mean the country's population in which you live, right? So that's a very important point we want to make very, very clear. So epidemiology doesn't care whether you live in Kenya or whether you live in Tanzania. It's about the population you are studying, the parent population, where they come from, how many of that population exists. So you have to refine that population in terms of what you're studying. Now, you don't need to know the exact numbers. If a rough estimate will suffice.
Thank you. And for those who are not aware, we have posted the attendance link. You can check the chat box. The next question, how can the survey created in this platform be filled by the respondent?
All right, a good question. You simply you launch a survey. First of all, let's reduce this. So to launch the survey, you would first of all click on this button that says launch survey. If it's not launched, then they won't be able to take it. So you launch your survey. So now my survey is launched. Survey was launched successfully. Step number 1. Step number 2, you can then share the link with them. So let's grab the link and then share. So to grab the link, you have this button here. So remember, this is our questionnaire. This is the questionnaire we're trying to launch. We've launched a survey already. So we can come here to share survey, this button here. So if you click on share survey, that opens up the options for you to share the survey to participants. You can, for online surveys, you can just copy the link and share in an email, or you can copy the QR code, or if you're sharing on social media, you can come to this point here that says share on social media and select which social media type you want to share, whether it's LinkedIn or whichever. If you have emails of participants which you wish to send to them via email, you come to this option that says upload emails to invite participants. So you click on that, and that allows you to then upload emails, and the platform will send the emails to them. So you have a broad range of options to pick from. But again, the easiest is just copy the link and share with participants.
Thank you. I think there is a confusion the difference between retrospective cohort study and retrospective cross-sectional study. Even in published articles, it says retrospective cohort study, but internally it is cross-sectional study. Could you say something here?
So there's no such thing as a retrospective cross-sectional study. All cross-sectional studies capture exposure and outcome at the same time. For you to be able to use a retrospective cohort, you must have a cohort defined. There must be individuals who, had a defining event, right, that you have in the past that you can then retrace and know what happened in that time period. If you don't have a defining event in the past, you cannot create it. So I could say, for example, my defining event would be, for example, individuals who were enrolled in, the University of Ibadan, for example, in first class of the university. That's the defining event here is admission into the program, right? So in that case, it's easy for me to go back in time and access the records of individuals who belong or who meet that defining event of interest, right? Without that, I cannot create I cannot reconstruct that cohort. Because remember that a retrospective cohort and a prospective cohort are the same thing. The only thing is that, well, one we're there and we followed, the other one we're just trying to reconstruct based on the video evidence, which is the records available, if you remember an analogy. So a cross-sectional study, bottom line, is a descriptive study. We're not interested in exposed or non-exposed groups. It's just a story of the population based on person, place, and time. A retrospective cohort study is an analytical study where we're interested in what happened to people who were exposed versus non-exposed, right? And we are going back in time based on a defining event and following them as though we were there at the beginning over time. So it's a comparative study. So they're very, very, very different. There's there's very little overlap between a cross-sectional study and a retrospective cohort. I hope that's clear.
Thank you. How do you ensure random sampling when using chi-squares in this kind of study if you cannot be in the field in person?
Well, the chi-squares platform can help you generate samples, but it's your job to. So, for example, if my survey is a survey of, let's go to sampling. If I want to draw a representative sample of, let's say, households in, let's say, Oyo State, right? And I want to do that with the platform, I can come here and select Start New Sampling. I'll select that I want to automatically draw a representative sample for the country, in this case, Nigeria. And for the state, Oyo State. Let's say, now the platform tells you that the number of clusters available is 33. The platform uses the second administrative unit as clusters. That means the first administrative unit is the state, the second is the local government areas. So that's our clusters. In general, you don't want to use below 8 clusters, right? To ensure your estimates are precise. So in the NCHS guidelines for precise estimates, that's the magic number, So we want to use no less than 8 clusters to ensure that we have sufficient, diversity in our responses. So of the 33, let's say we wish to select 10 of those clusters for our sample. This tells the total number of people you could sample. Let's say our sample size is 2,000 from that population. So we supply all of those things and we'll click on Get Sample. The platform will then tell you that here are the places where you have to go to select individuals to make sure that your sample is representative of that selected entity, geographic entity, right? So let's expand this, make it bigger. So here, this is saying, this is Oyo State. So it's saying, here are the places you'd have to go to sample if your sample is going to be representative of that location, or in this case, that state. Now, operationally, obviously, it's up to you now to implement what has been recommended, right? So what does that mean? It means that you would have to, I'll make this zoom this out. It means that you would have to go to the counties or the select. So here it says, these are the counties or local government areas that you'd have to go to. And here, these are the number of people you have to sample. The platform implements a two-stage PPS sample, which is sampling with probability proportional to size, where in the first stage, we select clusters with their selection probabilities proportional to their sizes, which means that bigger clusters are more likely to be selected. But in the second stage, we select a fixed number of people from each cluster, which means that in this second stage, the smaller clusters are more likely to be selected, which balances the selection probabilities. That makes a two-stage PPS a self-weighting sample. So if you were to follow this selection, you're going to get a representative sample for that state. But obviously, you are the one who now has to go to this Akinyele and say, all righty, how am I going to select 200 people there? And you go to the next one. So the platform can only help you say, all right, this is where you have to go. The operationalization of that is now up to you to make sure that you sample them in a way that is random or probabilistic.
Thank you. Sir, I got a quick question. Can you automate the Power BI to Chi-squares for real-time data monitoring and dashboarding?
Well, Chisquares already does that already, so you don't have to integrate it. Tomorrow we'll talk about the data analysis on the Chisquares platform. So, but all of that is, the Chisquares platform is an end-to-end platform for analysis and not just data collection. So that has already been integrated into the platform. So that on the platform, you can choose to, for example, visualize your data. So if this is your data set, you can perform different kinds of analysis that you want, including descriptive analysis or, sorry, logging back, or multivariable analysis or things of that nature. So there's no need for such integration because that has already been accounted for in the platform.
Thank you. Please clear your screen.
Okay, sure.
What is the appropriate sample size for a PhD research, sir?
What is the appropriate sample size for PhD research? That would depend on a million things. It depends on what the topic is, depends on the design. The question is unanswerable in its current form.
If a study included all study participants, for example, 600 hepatocellular carcinoma, which is census without using sampling, can we say that is externally valid?
Yeah, so in this case, yes, you took a whole sample, you took a census. Of course, you can, the assumption that it is external valid is true, assuming that there's no measurement bias. It doesn't matter whether I had everybody in the study, but they all told me lies. Well, that means that there's no truth in the study now. Remember that the premise for external validity is internal validity. You must have internal validity first before you can talk about external validity. If you don't have internal validity, you cannot talk about external validity. So if in this case, if all of the individuals, I'm just making an exaggerated scenario here, everybody told me lies about their smoking status, which was the question in the survey, it means I don't have internal validity. And that means that I cannot go ahead and talk about external validity because the very premise for which to execute external validity is missing. Individuals have provided responses that are full of measurement errors or measurement bias. So in this case, we can't even begin to talk about external validity where we don't have internal validity. But your point is very well clear. Yes, in theory, yes, we can. If you took a census, then we can obviously make inferences to the whole population. So that could hold true, yes. But under caveats, obviously.
Do Chi-squares handle environmental data analysis like remote sensing and GIS?
The platform has capability for analyzing geospatial data, but if you are talking about remote sensoring, well, that you will need some equipment of sorts. But once you have collected the data, the platform can analyze that for you.
How much does the premium features of the platform cost?
Well, that would depend on if it's an institutional license or if it's a individual license. But I think that's available on our website. So our team can drop the information on the chat, so you can access that information.
Thank you. Thanks, Elia, for sharing. Are there any other questions I might have missed earlier? If so, please post. Just repost. I am planning a study with community pharmacists in Ibadan as my study group. Is this a cluster sampling? And if yes, how many strata is it considering their knowledge may be similar?
The number of strata is completely up to you. That's a question, that's a study design question. And questions of study design will have to be answered by, I do not know what the context is. So in that form, the question is unanswerable in that way. Now, the first part of your question, that is it cluster sampling, that is also unanswerable without knowing how you are sampling them. If you have a list of all the pharmacists in the area and you are drawing a sample of those pharmacists, that's obviously a simple random sample and no clustering is involved, right? However, if you are drawing it from clusters, then that's a different issue. So it's just saying that you're doing a study of pharmacies is not sufficient information for us to determine whether or not there's clustering. Those are design questions which you are best qualified to tell us how you want to do it. So I hope that clarifies.
Thank you. Does the platform handle panel data analysis?
Yes, it does.
Right, I think that's the last question.
All right. So tomorrow's session will focus on analysis. So I thought there were a lot of questions on analysis. So we're going to handle them tomorrow. We're going to show you how you could, like, for example, develop a manuscript on the platform, from beginning to end. So that's what we'll cover in tomorrow's session. So we look forward to seeing you tomorrow. And if there are no other questions, we'll see you tomorrow then in class. Thank you very much.
Here lies a scientist who published, yet perished. But he published. Why did he perish? Because he took too much time. 4 years, 1 paper? Don't take 4 years to write a paper like this, man. Write your entire manuscript in just 1 day, from start to finish, with Chi-squares. Analysis, writing, referencing, all in one platform. Write smarter, live longer. Chi-squares.